Hi, I'm Yoshi. I'm going to talk about Unison today. Unison is this language with this logo. I recently made 2 libraries in Unison, so please check on the Unison share. Unison has many characteristics, but I'm going to focus on the first one today, which is a content address and UCM. So in Unison, all the functions and terms, the types are referenced by the hash of the AST, and the names are just the alias to the hash. So this is why it's called content addressed. And to achieve this one, the code is stored in a database as a serialized AST. And the Unison calls this a code base. So not a text file on your file system, but a code base stored, data stored in the database called code base in Unison. So we need a tool to access this code base. That's a Unison code base manager. And I will show you how to actually develop the Unison code. So first thing you do is to run the UCM. If you run the UCM, it brings me to the units project with the div branch. Because it's a unit conversion library, I prepared a lot of units already. So I want to see one of the units, for example, unit.volume. So I can see the code base here. But I want to add a pint to this volume. So when you want to edit something, you do the edit.volume, for example. Then this scratch.u file is created by the UCM, and then that code appears here as a text. So I can edit here, for example, add pints. Then after, if I save, the UCM detects the changes, and then I want to update this one. So with the update command, then suddenly some other parts of the code appears here. So by this change of the type, other parts of the code base, other functions that depends on this change, that might be affected by this change, appears automatically here. And with the help of the language server protocol, I can clearly see that which part doesn't compile anymore. So this is a symbol for that unit. For example, for the pints, we can declare like PT for the symbol. And the other parts becomes the error here. This is the declaration, the important part, the coefficient of the unit. 1.0568 liters. So then after fixing this compiler errors, everything type checks and no compiler errors. By the way, this README refers to this quantity.volume. So this changes, so this is also affected. That's why this appears here. Then after everything type checks and compiles, we can finally update. Done. Then actually we can just remove all the files here, because it was just a temporary file. So safely delete file. Then if I see the code base again, the pints appears here. Yeah, so that's how you update the Unison code base. But I realized that the pints are actually different in the UK and US. So I wanted to, before adding the US pints, I wanted to rename these pints to the UK pints so that it's clear. For that, we can use the command rename unit.volume.pints. So for example, unit.volume.ukpints. Done. If I see the code base again, yeah, of course, this changes. But not only here. Some other parts that use this type changes. For example, the symbol function that I just changed, the name changes automatically here. So you don't need to change every part, of course. It's the name is just an alias to the hash. So that's how the Unison manages code base. Yeah. Well, so as you see, the code update is really safe, easy, and quick. Which is really fun, actually. And it actually substitutes a lot of work that the IDE is currently doing, which is usually heavy and slow. So I see the future of programming here. So by using the data structure as a code base, it opens a lot of doors to a lot of possibilities. Yeah, that's it.